Okay, let's unpack this 5G thing. It's a term that's, well, it's practically everywhere now, isn't it?
It really is. Faster phones, next-gen tech.
The future of connectivity, they say.
Hmm.
But if we kind of strip away the hype for a second, what really is 5G? I mean, what does it truly promise? And maybe what are the surprising challenges or even threats it
That's
carries?
the core question.
Today, we're doing a deep dive into the world of 5G. We've got a stack of sources covering everything from the tech marvels to, yeah, some of the bizarre controversies, too.
Hmm.
Our mission here is simple: give you a shortcut to being genuinely well informed, cut through that noise, and find the really important nuggets.
And what's so fascinating, I think, is that 5G isn't just, another small step up from 4G.
Hmm.
It really represents a fundamental shift in how we even think about connectivity and what it can do.
Right.
Our sources, they highlight this incredible potential, almost science fiction stuff sometimes, but they also lay bare some significant hurdles.
Hurdles like?
Oh, technical limitations, definitely, but also these deeply entrenched societal concerns.
Okay, get ready for some aha moments then, because this deep dive is going to show why 5G is so much more than just a speed boost for your phone. We'll get into the unexpected applications and, yeah, try to unravel some of the weird misinformation floating around.
There's quite a bit of that.
So let's start right at the beginning. What exactly is 5G, fundamentally?
Okay, so at its core, it's the fifth generation of cellular network technology. Follows 4G, obviously. And it's been rolling out more or less globally since about 2019.
But just saying 4G but faster, that doesn't really cut it, does it?
Not at all. That's a massive understatement, actually. If you step back and look at the bigger picture, the key improvements are pretty profound compared to 4G. Our sources point to, first, speed. Theoretical peak download speeds could hit 10, maybe 20 gigabits per second, GBPs,
Which is roughly.
and are 10 times faster than 4G, potentially. But exactly. So, for example, average 5G speeds were clocked at 186 megabits per second in the U.S. by T-Mobile. And over in South Korea, back in May 2022, they were hitting an impressive 432 megabits. So it's definitely faster in practice.
Okay, that's a serious jump. But you said it's more than speed. What's the real game changer here?
Indeed. This is where it gets really interesting for a lot of the transformative applications. Latency.
Latency, the delay.
Right. 5G offers substantially lower latency. We're talking near instantaneous communication. Think ideal air latency. That's the time just through the air, around 8 to 12 milliseconds.
Wow.
And if you add edge servers close to the towers, the total round-trip time can drop to about 14 milliseconds.
That's incredibly fast. Faster than human reaction time.
Faster than your brain registers seeing something, basically. So, for critical stuff, remote surgery maybe, or a self-driving car, making split-second choices, this isn't just fast, a whole new level of control.
A new paradigm, you called it.
Exactly. And beyond speed and latency, capacity. 5G networks are designed for something like a 100-fold increase in network capacity and efficiency over 4G.
So handling way more devices at once.
Vastly more. And another crucial point.
Yeah.
Unlike the old days with competing standards, there's one global unified 5G standard. It's called 5G New Radio, or 5G NR.
Okay, so near instantaneous is actually real, not just marketing fluff. That's genuinely remarkable. What kinds of things does this low latency and massive capacity actually open up for us, for you listening, beyond just a faster phone?
Yeah, and this brings up a critical point. Why should you care about all this? The International Telecommunication Union, the ITUR, they actually define three main application areas for 5G. And interestingly, only one is really fully deployed in most places right now.
Okay, what are they?
First is Enhanced Mobile Broadband.EMBB. That's the faster connection we usually think of.
The one for streaming 4K video, downloading big files fast.
Precisely. Especially useful in crowded places like stadiums or concert halls where 4G would just bog down.
Right, but you said there were three. What else?
Then we get into the really transformative stuff. Ultra-reliable low-latency communications, or URLLC.
Okay, that sounds serious.
It is. This is for mission-critical applications, things where an interruption, even a tiny delay, could be, well, catastrophic.
Like what, for instance?
Think controlling industrial robots on an assembly line with perfect precision, or managing a smart power grid in real time. The stakes are incredibly high there.
Got it. And the third?
Massive Machine Type Communications, MMTC. This one is designed to connect Literally billions of IoT devices.
The
Billion.
Internet of Things devices.
Yeah, everything from tiny sensors in a smart city monitoring air quality or traffic flow to automated systems in farming or even just the smart utility meters in your house.
Okay, this is where those unexpected applications really start to shine, painting a picture way beyond just smartphones. Like digital twins, I read about this, creating real-time virtual models of physical things.
Exactly. Imagine a huge offshore wind turbine. Instead of sending engineers out in dangerous conditions, you have a perfect virtual copy running in parallel, fed by real-time sensor data over 5G. You can monitor it, analyze it, predict failures.
All from shore. That's huge for safety and efficiency.
Absolutely.
Yeah.
Then there's public safety. Think enhanced push-to-talk video data for emergency responders. Much more reliable, much faster in a crisis.
Crucial when seconds count.
And for homes and businesses, especially outside big cities, fixed wireless access, or FWA.
Using 5G like a replacement for cable or fiber internet?
Precisely. Delivering high-speed broadband wirelessly. It's a potential game changer for closing the digital divide in rural or underserved areas where laying fiber is just too expensive.
That could make a massive difference to people.
It really could. And the list goes on. Think wireless video transmission. Sony's even tested using local 5G to replace bulky cables on broadcast cameras.
Making live TV production much more mobile.
Yeah.
Exactly. More flexibility than autonomous vehicles. Now, they don't need 5G to drive themselves locally. They have onboard sensors.
Right.
But for teleoperations, that's a remote human taking control in a tricky situation. 5G's low latency is vital. Imagine needing to steer a car from miles away with almost no delay.
Yeah, you'd need that instant response.
And we're even looking beyond the ground now. Standards are being developed for non-terrestrial networks, NTN,
Meaning?
using satellites, high-altitude platforms to extend 5G coverage literally everywhere. Remote oceans, mountains, deserts, companies like Samsung, MediaTek, Qualcomm, they're already building hardware that integrates 5G with satellite capability.
Wow. So connectivity truly anywhere on the planet.
That's the goal. If you step back, you see these applications driving huge changes across healthcare, transport, entertainment, fundamentally altering how industries operate.
It really is a massive leap beyond just faster movie downloads.
Yeah.
So, okay, how does 5G actually do all this? It's obviously not magic. It must be some clever tech and using radio waves differently. Precisely. It's a combination of new technologies and smarter use of the radio spectrum. 5G operates across 3 main frequency bands, and each one has its own pros and cons.
Okay, let's break those down. What's the first?
First, you've got low band. This is also called frequency range 1, uses frequencies below 6 gigahertz, often in the 600 to 900 megahertz range, similar to 4G.
So similar range to 4G towers too. Good coverage.
Yeah, decent coverage, signal travels pretty far, penetrates buildings reasonably well. Speeds are okay, maybe 50 to 250 megabits per second. Good foundation layer.
Okay, solid, but maybe not the super fast speeds people talk about.
Exactly. For faster speeds, you generally move up to mid-band, still in frequency range 1, but using microwaves, typically 1.7 to 4.7 gigahertz.
And this is common in cities.
Very common.
Yeah.
It's often seen as the sweet spot, balancing good speed, maybe 100 to 900 megabits per second with decent range. Cell towers can cover several kilometers. This is probably the 5G most people experience day to day right now.
Right, that makes sense. So where do the gigabit speeds come in?
That's the high band, or millimeter wave. There's a frequency range 2, way up there, 24 to 47 gigahertz. This is where you get those potential gigabit per second speeds.
Ah, okay. But I feel like there's a but coming. I've heard millimeter wave has issues.
Yes, there's a significant trade-off, a big but. Millimeter waves have very, very limited range. We're talking hundreds of meters, not kilometers.
Really? That's short.
Yeah. And they really struggle to penetrate obstacles, walls, windows, even leaves on trees, or the human body can block or weaken the signal significantly.
So how do you make that work in a city?
It requires a really dense network of what are called small cells. Lots of low-powered radio nodes, almost like Wi-Fi hotspots mounted on lampposts, buildings,
Yeah.
close together, especially in busy areas.
Okay, so different frequencies for different needs. Makes sense. But what about the tech behind the frequencies? Our sources mentioned some interesting things.
Absolutely. Beyond the spectrum, several key technologies make 5G tick. One of the biggest is massive MIMO.
MIMO, multiple input, multiple output.
Exactly, but on a massive scale, using dozens, even hundreds of small antennas as a base station and multiple antennas on your device.
And that does what? Boosts capacity.
Hugely. It allows the tower to communicate with many devices simultaneously, much more efficiently. Think of it like going from one big floodlight covering everyone dimly to hundreds of individual laser pointers, each focused directly on a user.
Better signal, less interference.
Precisely. Then you have those small cells we mentioned, absolutely essential for making high-band millimeter wave practical.
Right. And beamforming. I read about that too.
Yeah, beamforming is clever. Instead of broadcasting the signal out in all directions, like a traditional radio tower,
Wasting energy.
right, beamforming uses signal processing to focus the radio waves into a specific beam, pointed directly at the user's device.
Like a spotlight for data.
Exactly. Stronger signal for the user, less interference for others, more efficient use of power.
Clever. And one more, edge computing. How does that fit in?
Edge computing is crucial for that low latency we talked about. It means moving computing power and data storage closer to the edge of the network, nearer to the user.
Instead of sending data all the way back to a central cloud data center?
Correct. Processing data locally, right near the cell tower, or even closer, dramatically cuts down the round-trip time. Makes that near-instant response possible for things like connected cars or real-time analytics.
Okay, that paints a clearer picture. But technology doesn't stand still. What's next? I heard about 5G Advanced.
Yeah, that's already happening. Sometimes called 5.5G. It's defined under the 3GPP Release 18 standard. Think of it as a bridge towards 6G.
And what does that bring? Even faster speeds?
Potentially, yes.
Yeah.
Theoretical targets are around 10 Gbps downlink, 1 Gbps uplink. But it's more than just speed. It aims to connect maybe 100 billion devices.
Wow.
It also integrates AI and machine learning directly into the network for optimizing performance, managing traffic.
The network manages itself better. Sort of, yeah. It also enhances network slicing. That's the ability to create dedicated virtual networks on top of the main 5G infrastructure, each tailored for a specific need.
Like a private lane on the highway for critical applications.
That's a great analogy. Guarantees performance for things that need it. 5G Advanced also aims for near-zero handover time moving between cells without dropping connection, and even adds independent geolocation without needing GPS.
So your device could know where it is even indoors or underground.
Potentially, yes. Crucial for logistics, emergency services. And it's not just theory. Places like Finland and China are already deploying 5G Advanced features.
Okay, so the potential, the promise of 5G and its evolution, it's clearly immense, really pushing the boundaries. But as you said earlier, powerful new tech often comes with challenges, controversies even. Our sources definitely dig into some significant concerns we need to talk about.
Absolutely. And it's really important here to, look at these critically, understand the different viewpoints without necessarily taking sides, just reporting what the sources highlight. Right. So what's the first big area of concern?
One major one is security. With billions, eventually maybe trillions, of IoT devices connecting everything from your fridge to industrial sensors, the potential attack surface for cyber attacks just explodes.
More devices mean more ways for bad actors to get in.
Exactly. More potential vulnerabilities for things like distributed denial of service, DDoS attacks, where attackers overwhelm a network with traffic from compromised devices.
And there are geopolitical concerns too, right? The whole Huawei issue.
Yes, very significant geopolitical dimensions. Our sources mention a U.S. House report back in 2012, for instance, concluding that equipment from Chinese vendors like Huawei and ZTE could pose risks to U.S. national security interests. This led several countries, US, UK, Australia, others to restrict or even ban the use of their equipment in critical 5G networks.
Why? What was the specific concern?
Concerns about potential state-sponsored espionage, backdoors in the equipment, or the ability for a foreign government to disrupt or shut down networks in a conflict. There was also the Clean Network Initiative, pushed by the U.S. State Department, aiming to create an alliance of countries using only trusted vendors, citing data privacy and security threats from, quote, authoritarian, malign actors.
Okay, so serious security and geopolitical implications. What else? You mentioned hurdles earlier.
Another complex area, one that's generated a lot of headlines, is electromagnetic interference.
Interference with other important systems.
Yes, a major concern involves weather forecasting. Some 5G frequencies, particularly around the 24-26 gigahertz band, are worryingly close to frequencies used by satellites to monitor water vapor in the atmosphere.
And water vapor data is critical for weather models.
Absolutely critical. The acting head of NOAA, Neil Jacobs, testified to the U.S. Congress in 2019 that interference from 5G emission signals leaking outside their assigned band could degrade weather forecast accuracy by as much as 30%.
30%? That's huge. Could that mean missing major storms?
He specifically raised the possibility of impacts, similar to if forecasting had been degraded back during Superstorm Sandy. International bodies like the World Meteorological Organization, the WMO, have been debating safe emission limits. Atmospheric scientists generally argued for much stricter limits than some regulators initially proposed, warning that the current international standard might not be protective enough.
That's a serious worry, and it's not just weather, right? Aviation also had issues.
Yes, particularly in the U.S. The aviation sector raised alarms about 5G operating in the 3.7 to 3.98 gigahertz band, potentially interfering with aircraft radar altimeters.
Altimeters, the things that measure height above ground for landing.
Exactly. They operate nearby between 4.2 and 4.4 gigahertz. The concern was mainly with older altimeters potentially being susceptible to interference from powerful 5G signals near airports.
Did this cause actual problems?
It did. It led the FAA, the Federal Aviation Administration, to ask AT&T and Verizon to delay rolling out 5G near about 50 major airports in early 2022. There were some flight cancellations and disruptions as airlines updated equipment or procedures.
Why was this mainly a U.S. issue? Didn't Europe have the same problem?
Interestingly, less so.
Yeah.
Europe generally uses slightly lower frequencies for its main 5G band, 3.4 to 3.8 gigahertz, providing a bit more separation from the altimeter frequencies. It really highlights how complex and sensitive spectrum allocation is.
Wow. Okay, so security risks, interference risks. What about the hype factor? Some sources question if 5G is maybe overhyped.
That's definitely a thread in the discussion. Is the individual customer experience going to be as dramatically changed as some of the marketing suggests?
Or is a lot of the improvement maybe being misattributed to 5G when it's just general network upgrades?
Right. And is the focus too much on, slightly faster downloads for consumers rather than the truly revolutionary potential in IoT or industrial uses or solving that last mile internet access problem with fixed wireless access?
It's a fair question. Who benefits most and when?
It leads us neatly into perhaps the most visible and often disturbing aspect of 5G's challenges: misinformation.
Ah, yes. This seems to follow any new wireless tech, but 5G took it to another level. Let's start with health concerns.
There's a long history of public anxiety about radio waves, going back to power lines, then mobile phones.
And 5G got hit with rumors about causing cancer?
Yes, but that's widely considered a myth by the scientific community. In fact, experts point out that the high-frequency millimeter waves used for the fastest 5G are non-ionizing radiation. They're actually less able to penetrate the body than lower frequencies.
So they can't even reach internal organs.
Generally, no. They're mostly absorbed by the skin. Official health organizations worldwide maintain that 5G, operating within established safety limits, poses no proven health risks.
But the fear spread anyway.
It did. Fueled by some questionable studies, maybe some deliberate propaganda sources. Mention RT America, for example, linking 5G to various illnesses. And this fear had real consequences. Some local governments, places like Brussels, Geneva, parts of the UK, actually paused or halted 5G deployments specifically because of public radiation concerns, despite scientific consensus.
A real case of fear over fact, then.
Absolutely. But perhaps the most alarming and frankly bizarre misinformation linked 5G to the COVID-19 pandemic.
Oh, I remember this. Utterly baseless conspiracy theories.
Completely discredited. Theories claiming 5G radiation somehow caused COVID-19 or weakened immune systems, making people susceptible. Scientifically impossible. Viruses cause COVID-19, not radio waves.
But these theories spread like wildfire online.
Tragically, yes. And they led to real-world violence. Dozens of arson attacks on cell phone masts across Europe, the UK, and elsewhere.
People actually setting fire to critical infrastructure based on these conspiracies?
Yes. Damaging communication networks that people, including emergency services, rely on. The World Health Organization had to issue specific mythbusters to combat these dangerous claims directly. It is a stark example of how damaging misinformation can be.
So, wrapping this all up, what does this mean for you listening right now? We've gone from 5G's incredible speeds and potential to transform industries like transport and healthcare with things like autonomous vehicles and digital twins, all the way to heated debates about national security, worries about interference with crucial systems like weather forecasting and aviation safety, and then this wave of misinformation, even leading to violence. It's clear 5G is a technology with really profound, really complex implications.
Absolutely. If we step back, connect it all, 5G is undeniably a powerful engine for progress. It offers unprecedented opportunities across almost every sector imaginable, but realizing that potential responsibly, that depends entirely on how we as a society navigate these complexities.
Meaning we need to address the legitimate concerns, security, interference with solid science, and careful planning.
Exactly. And at the same time, combat the unfounded fears, the misinformation, with accurate, clear communication. It's a balancing act.
We've taken you from the promise to the problems and tried to cover everything in between. But maybe here's a final thought for you to mull over. Given these incredible advancements, 5G offers enabling smarter cities, maybe even remote surgery one day, but balancing that against the real technical hurdles, the spectrum fights, the security worries, and this alarming rise of conspiracy theories. How do we collectively ensure this powerful technology gets rolled out responsibly? How do we make sure it's understood accurately, used for everyone's benefit, without falling victim to either hype or fear?
That's the multi-billion-dollar question, isn't it?
It certainly is, and it's a conversation that's really just beginning.